Friends, good evening. Once again, welcome in my home class. And today we are going to discuss about the real numbers and different axioms related with real numbers. And before this, we had discussed about the set chapter, and we had also discussed many more theorems that had given in the chapter of set, and also some important questions that had appeared in your board examination. Okay, so hope you are going through all those videos. Now let's enter in the real number. So first of all, I have made one categorization of the real numbers. So real number is categorized into, so here we see real number is categorized into two subcategories, rational number and irrational number. Okay, so what is rational number? It is a question. Okay, you might have read in your lower class also. So rational numbers means all that type of numbers that can be expressed in the form of a upon b. Okay, a upon b, where b is not equal to 0. Whatever the number you get, that is rational number. Like for example, if you are taking 5, so 5 is rational number because it can be expressed in the form of 5 by 1. Similarly, suppose 1 by 2. 1 by 2 also is a rational number, it is in the form of a by b. But also, one more important property of rational number, we should always remember that rational numbers are all that type of numbers which are terminating or reoccurring. Okay, so like for example, if we take 1.5, yes, 1.5 is terminating decimal number, so it is rational number. Okay, similarly you may take suppose 3.33333, that is reoccurring, so that is also a rational number. But if you take a different types of numbers, like suppose pi, so what is the value of pi? 22 upon 7, and if you calculate this, you will get 3.14 something. It will neither be terminating nor it will be reoccurring. So these type of numbers are irrational numbers. Next example of irrational number, you may take the example of root 2. You can use your calculator and you just see the value of root 2. You will get it neither terminating nor reoccurring. So they are irrational numbers. So just remember one key point, that terminating or reoccurring numbers are rational, and non-terminating and non-reoccurring are irrational numbers. Okay. Then after, let's go to the further categorization. So rational numbers are again further categorized into integers and fractions. Okay, so fractions, like I have taken an example, suppose 1 by 2. So this 1 by 2 is a fraction. You may take 5 by 2. 5 by 2 is a fraction. Okay, but if you take the numbers with except the fractions, like if you are taking 2, so 2 is categorized in the form of integer. Maybe -3, that will be integers. Okay, negative, positive number may be of any type. So all types of numbers are included in the real numbers. Okay, we are not discussing here imaginary numbers, we are only discussing about the real numbers. So whatever the numbers you see in your life, they all are real numbers. Okay, except imaginary. So let's not introduce imaginary over here. We will discuss it when we will read complex number. In that chapter we will discuss about imaginary numbers. Okay, so here integers and fractions are the two categorizations of rational number. So integers are again categorized into three types. They are negative integers, 0 and positive integers. Okay, so in the real line, if you see 0, so on the left side it will be -1, -2, -3, -4 and so on. On the right side it will be 1, 2, 3, 4 and so on. So these are the negative integers on the left side. On the right side they are the positive integers and it is 0. So overall they are all, as a whole, they are called integers. Okay, and one more thing, let's go to the notation. So real number is its notation. The set of real numbers are denoted by this type of symbol r, or simply you can write r as well. Okay, similarly rational numbers are denoted by q, integers are denoted by z. Okay, or simply you can write z as well. So now here I have given one relation among all the types of numbers. So here we can see n means set of natural numbers. Okay, So set of natural number is the subset of set of integers. Set of integer is the subset of rational numbers, and set of rational number is the subset of set of real number. So please go through this. Now let us enter in different types of axioms, that is addition axiom and multiplication axiom that are related with real numbers. Okay, so let's go in that portion now. Okay, so now let us enter in the different axioms of real numbers. So first of all, I am going to introduce with addition axiom. Okay, so in addition axiom, so whatever the real numbers you take, okay, so all those real numbers, they bear all these different types of properties. Okay, so suppose if you are taking any real number, the set of any real number R, okay, so whatever the elements you take in the real number, whatever the elements may be A, B, C, D, suppose all these are real numbers that belong to the set R. Okay, so closure property, what does this property say to us? What does this property say to us? So this property says that, I am not going to write all completely, please follow me and follow my sentences. So closure property says that if you take any two real numbers a comma b belongs to real number, the set of real number, suppose a comma b belongs to the set of real number, then their sum, if you add them a plus b, whatever the result you get, the sum will also belong to the set of real numbers. Okay, suppose for example, if you take the example 2 and 3 are the real numbers, so if you take 2 plus 3, it will be 5, so 5 will also be a real number that will belong to the set of real number. So we can say that the set of real number is closed under addition. Okay, so it is the closure property. Now let us go to commutative property. So again, commutative property states that if a comma b belongs to the set of real number, okay, then a plus b will be equal to b plus a. Okay, so you can imagine some example in your own mind. Take some example of the values of a and b. Suppose a is 5, b is 7. So 5 plus 7 is 12, and 7 plus 5 will also be 12. Okay, so a plus b is equal to b plus a. This property is called commutative property of real numbers. Okay, now come to associative property. So associative property says that if a comma b comma c belong to the set of real numbers, then associativity, then a plus bracket b plus c, this will be equal to a plus b in the bracket plus c. So if you shift this bracket towards the left side also, you will get the same result. You can calculate it by taking some examples in your mind of the value of a, b, c. Take suppose 1, 2, 3, a means 1, b means 2, and c means 3. So 2 plus 3, 5, 5 plus 1, 6. Okay, so here 1 plus 2, 3, 3 plus 3, 6. You will get the same result. So this property gives the associativity of the real numbers. Now come to additive identity. So this will be if a belongs to the set of real number, okay, then additive identity a plus something is equal to a. So my question is, what will you add to the a to get the same result? Identity. Okay, what you have to add here with the a to get a? What do you have to add? Say me. What you have to add in a to get a? So obviously it will be 0. If you add 0 to the a, you will get the same result a. A plus 0 will be equal to a. Okay, so hence we can say that 0 is the additive identity. 0 is the additive identity of a. Okay, so suppose you can take some examples about 3. In 3, what you have to add to get the same result? In 3 you have to add 0 to get the same result, 3. So 0 is the additive identity of 3. Okay, so 0 is additive identity of any real number. Okay, So it is about additive identity. Now come to additive inverse. Okay, so if in additive inverse, if a belongs to any real number, then in this a, what you have to add to get the value 0? Okay, in a, what real number you have to add to get 0? So obviously you have to add minus a. So a minus a will be equal to 0. So what we can say that hence minus a is the additive inverse of of a. Okay, so let us take one example. Suppose you are taking 5. So in 5 you have to add minus 5 to get 0. So minus 5 is the additive inverse of 5. Okay, so we are clear about all this addition axiom. Now let us go to multiplication axiom. So same like addition axiom, now here I have brought multiplication axiom to all of you. So multiplication axiom is also same as addition axiom. In place of plus, just we have written multiply or product or dot. Okay, so in closure property it will be, if a comma b belongs to some real number, the set of real number, then a into b also belong to real number. You can go through some example like 2 into 3, 2 and 3, a to b3. If they are real numbers, so 2 3 is 6 will also be a real number. Okay, that is closure property. So we can say that the set of real number is closed under multiplication as well. Similarly, come to commutative property. If a comma b belongs to some real number, then a into b is equal to b into a. That is commutative property of multiplication. In addition it was a plus b is equal to b plus a, but in multiplication it is a into b is equal to b into a. Now come to associative property. So in associativity what we get is, if a comma b comma c belongs to the set of real number, then a into bracket b into c is equal to bracket of a into b into c. Same like addition, in place of plus there is product. Similarly, multiplicative identity. So let us learn this now. If a belongs to the set of real number, then a into what is equal to a. What we have to multiply in a to get the same result? So obviously we have to multiply 1. A into 1 is equal to a. So here we can say that hence we can say that 1 is the multiplicative identity. 1 is the multiplicative identity of a. Okay, similarly you can take some example like 10 into 1 will be 10, so 1 will be the multiplicative identity of 10. Now come to multiplicative inverse. So if a belongs to some set of real number, then a into, obviously a inverse will be equal to 1. Okay, so in a you have to multiply a inverse to get 1. So we can say that hence a power minus 1 is the multiplicative inverse of a. So if you take suppose 3, so 3 into 3 power minus 1, or you may say 1 by 3 is equal to 1. Okay, you can take some example, suppose 3 into 3 power minus 1, it will be equal to 1. Okay, so 3 power minus 1 is the multiplicative inverse of 3. Okay, so along with this, now let us go to learn one more property, that is called distributive property. So let me erase this portion. Okay, so here is the distributive property. Let us see, if a comma b comma c belong to the set of real numbers, okay, then a bracket b plus c, this will be equal to ab plus ac. So this a will be multiplied to both a into b plus a into c. This property is called distributive property of real numbers. Okay, you can create your examples yourself and you can check whether it is right or not. On the left hand side take some real numbers and check, and on the right hand side put the same values of a, b, c and check, you will get same result. This property is distributive property because here this a is distributed to b also and it is distributed to c also. Okay, now let's go to next topic. Okay, so now order axiom, what does it define to us? So it states that if we take any real numbers, or we can say if we take any positive real numbers, if we take a real number a greater than 0 and b greater than 0, okay, a comma b belongs to the set of real numbers, then if you multiply a and b, ab, this will also be greater than 0. It will also be a positive real number. Suppose if you take 5 and 10, both are positive real numbers. So 5 into 10, 5 10 is 50 will also be a positive real number. So this axiom is called order axiom. Now come to axiom of trichotomy. Okay. So what does this axiom say to us? What information does it give to us? So here if we see, if a and b are any two real numbers, then only one of the following relation holds. Only one of the following relation holds. Okay. So if you are taking any two real numbers a and b, then there are three relations among which only one will hold at a time. So either a will be less than b, or a will be equal to b, okay, they may be equal, or a will be greater than b, okay. So two relations at once cannot hold. Among all these three relations, only one relation will hold at a time. For example, if you are taking 3 and 1 by 2, so obviously 3 is also a real number, 1 by 2 is also a real number. So here 3 is greater than 1 by 2. So this relation, a is 3, b is 1 by 2. This relation holds. Okay. Similarly, if we are taking 5 and 5, so both are real numbers, here equal relation holds. So among these three relations, at a time only one relation can hold at a time. This law is called axiom of trichotomy. Okay. Now let's move ahead. Now let us see the axiom of transitivity. So what does this axiom say to us? Let us see. So if a is greater than b, we are totally dealing with real numbers. Don't forget that. Now whatever the numbers we take, they will be the elements of the set of real numbers. So if a is greater than b, b is greater than c, then this will imply that a is greater than c. Okay, like for example, if you take a greater than b, means suppose 5, take the value of a, suppose 5, and b 4. 5 is greater than 4, and take the value of c, suppose 2. So 4 is greater than 2. So obviously 5 will be greater than 2. Okay, it is called axiom of transitivity. We may take its opposite portion also, like, or if a is less than b, b is less than c, then this will imply that a is less than c. So this axiom is called axiom of transitivity. Now let's move ahead. Now let's see axiom of Edison. So what does this axiom say to us? That is, if a comma b comma c belongs to the set of real numbers, means if a, b, c are any real numbers, and then we can say that then a greater than b, if we are taking one relation a is greater than b, then this will imply that a plus c will be greater than b plus c. If you add plus c on both sides, then the sign will not be changed, the sign will remain same. Similarly also, or if you take a less than b, then if you add c on both sides, a plus c, this will be less than b plus c. Okay. So what you understand, that if you are taking any inequality, and if you are adding the equal quantities, then the sign of inequality will not be changed. Okay, like for example, if you are taking, suppose 5 is less than less than suppose 7, obviously 5 is less than 7. So if you are adding equal quantity to the both terms, suppose 2, 5 plus 2 and 7 plus 2, the sign will not be changed, that is 7 is less than 9. 5 plus 2 is 7. 7 plus 2 is 9. So the sign will always remain same in addition. But in multiplication, it will be varied according on the basis of the real numbers you are putting over there. Okay, so let us go to the axiom of multiplication now. So this axiom now, axiom of multiplication, it states that if a comma b comma c are the element of in the set of real numbers, then if you are taking any relation, suppose a is greater than b, then this will imply that a into c will be greater than b into c. The sign will not be changed, only in the condition if c is positive number, that is c is greater than 0. Okay, if c is greater than 0, then the sign will not be changed. Okay, similarly, one more thing, also suppose if a is greater than b, then this will imply that a upon c will be greater than b upon c. The sign will not be changed in this condition. Okay, so if c is greater than 0, so please remember this condition. If c is a positive number, then the sign will not be changed. Okay, and after this, again, if a is greater than b, then a into c, if we are multiplying equal quantity on both sides, and if a is greater than b, then ac is less than bc, the sign will be changed if c is a negative number. Okay, if c is less than 0, then the sign will be changed. Similarly, here also, if a is greater than b, then a by c will be less than b by c if c is less than 0. Okay, like come to the example, suppose you are taking 5 is greater than 3. Suppose let us take two numbers, 5 is greater than 3. Now if you take any value, suppose that is positive number, okay, in place of c let us take any one value that is positive number, let us take 2. So if you multiply 5 into 2 and 3 into 2, you will get 10, and here you will get 6. So obviously 10 is greater than 6. We are taking the value of 2 positive value, and we are multiplying it on both sides, so the sign is not changed over here. Okay, similarly, if you take any negative value now, let us see. So 5 greater than 3, let us take any, suppose if you take negative value minus 2, so if you multiply it with minus 2, 5 into minus 2 and 3 into minus 2, what will you get? You will get minus 10 here and minus 6 here. So obviously minus 10 will be less than minus 6. So here sign will be changed if you take the value of c negative or less than 0. Okay, same in case of division also. Okay friends, now let's stop here for today, because we have many more things to learn, and if we continue all things at once, then the video will be too long. So I will give my next contents in my next videos. Till then, study hard, stay safe, do not go outside of your home in this quarantine period, because corona is affecting all over the world. So may God keep you healthy. Okay, so saying this much, okay, thank you, good night. And also at last, don't forget to subscribe and share my videos. Thank you.